Hey guys, I'm here to help you get started on the notes for the next section, which deals with inscribed angles in a circle. Alright, so the first thing I'm going to do down here is pretty much just define what exactly I mean by an inscribed angle. So inscribed angles, if it'll fit on this line, are angles whose vertex, right, so that's the point where the angle comes from, is on the circle, so that's point B down here, and whose sides are actually going to be chords of the circle. All right, so my two chords here would be AB and CB. So this is my inscribed angle. Now it's a little different from the angles we talked about in the last section, which was a central angle. So as you can see, this one stretches all the way across my circle. The next term over here focuses on the arc that lies on the interior of the inscribed angle. So what I mean by that is this arc right here, arc BD. And what we call that is the intercepted arc. Right, so the intercepted arc in my first example would be arc AC over here on the left. Now, in the first section, when I dealt with central angles, it was easy because, for example, this central angle up here was the same measure as the arc. So if the angle was 90, then the arc was going to be 90. All right, but with these intercepted arcs and inscribed angles, all right, the difference is that it stretches all the way across my circle. All right, well, this is definitely going to be smaller than if I had the central angle coming from the middle of my circle. All right, and the difference is that the measure of the inscribed angle is going to be half the measure of the intercepted arc. So they give me my equation right down here. So let's say, for example, that the measure of angle CAT is, I don't know, 40 degrees. All right, that means that the intercepted arc that it opens up to is going to be 80. All right, so whether you want to think about it as half or double, it's up to you. So let's try to get it started on a couple of these examples. So before I start answering all the questions that they're asking, let's just focus on what's given in the picture. I know that this angle right here is 50 degrees. So that means that the intercepted arc that it opens up to is going to be double that amount, which gives me 100. The other thing I notice is that this segment right here is a diameter, which makes this arc all around here a semicircle. So the whole thing's going to add up to 180. Well, we already have 100 on the left-hand side, which means that arc QR is going to be 80. Next thing I notice is that we have 48 for this intercepted arc on the left, or sorry, on the right. So what I'm going to do is find this inscribed angle using the intercepted arc. I know the inscribed angle is going to be 24. All right, so I think I have pretty much everything I need in my picture. So now I can run through these questions. First thing they want is the measure of angle T. I just got that, 24 degrees. Next thing I'm looking for is T to Q. So that's this arc over on the left, and I knew that was going to be 100. And the last one I'm looking for is Q to R. So that was the top arc that I filled in earlier using the semicircle, and that arc was 80. For the next problem, I'm going to start off the same way. Focus on what you're given, try to fill in anything you can. So we have 100 degrees for this intercepted arc, so that tells me that this inscribed angle is going to be half the measure of that arc, which is going to be 50 degrees. Then down here, it's the exact opposite. I have the inscribed angle, which is 35 degrees. I'm focused on the intercepted arc, which would be DA in this case. So all I have to do is take that 35 and double it. Now, I could also find the other arcs. I know that this is a diameter, which tells me that this is a semicircle on top. Well, we already have 100 on the right, which means that this top arc from D to E has to be 80. And down here, same thing. This is a semicircle. I have 70 on the left, which means that A to B has to be 110. So for the questions, they're asking for EDB. So E to D to B would be this angle. We already filled that one in. I know it's 50. And for the last one, the arc they're looking for is A to B to D. So I'm going from A to B and then to D. It's definitely a major arc. There's a lot covered here. So it's 110, 180. Or what I could do is, instead of going all the way around, the only piece I didn't cover was this 70. So I can take that out, and I'm left with 290. Now, for the last problem, there's going to be a little bit more work involved. I can already tell I'm going to have to set up an equation to solve for x and find this angle and arc length. Now, what I'm going to have to do is remember the relationship between the inscribed angle and the intercepted arc. These two expressions are not just going to be equal to each other. So for example, if this arc was 100 degrees, I would know that this angle was half that, 50. So to get these two expressions equal to one another, what I'm going to have to do is change one of them. So I'd either have to split the 100 in half to get it equal to 50, or I would have to double the 50 to get it equal to 100. All right, so let's keep that in mind when setting up my equation. I think it's going to be easier if I double the inscribed angle. So when I go to set up my equation, I'm going to do 2 times angle EFG and then set it equal to arc EG. All right, so now I'm going to have 2 times 8x plus 10 and then equal to 12x plus 40, which is going to give me 16x plus 20 equals 12x plus 40. Then once I combine my terms, we end up with 4x on the left, 20 on the right. I'm going to find that x is 5. But the last thing I need to do is actually plug it in. So I know I'm going to have 8 times 5 plus 10, which gives me 40 plus 10, which is actually 50. So my initial guess was right. And for the other one, we'll just check to make sure we're getting the right thing. It'd be 12x plus 40, which would give me 60 plus 40, which gives me 100. So I know that x is 5, EFG was actually 50, coincidence, and arc EG was 100. So for the next theorem in this section, I'm talking about inscribed angles still, but I'm talking about multiple in this case. So we have angle ADB and angle ACB in my circle. So if 2 inscribed angles of a circle intercept the same arc, so the arc in this case would be AB, both of them intercept arc AB, then the angles are, we could say, congruent, or I could say that their measurements are equal. Right. Which makes sense, because whatever these angle measures are, they'd have to be the same because they're both opening up to the same arc. So let's say this arc is, 50 degrees, then both of these angles in here must be 25. They have to be half that intercepted arc length. So let's see if we can apply this theorem. So for this next example, the only piece of information they give me is that this little arc all the way on the right is 20 degrees. Now, in this case, we have two we have two inscribed angles that open up to that. So I can immediately solve for their angle measures because I know the intercepted arc measure that they open to. So I know that this this inscribed angle is going to be 10, half the measure. This inscribed angle is going to be 10. All right, and that's what they're asking for, the measure of angle U and the measure of angle T. Next one, now I'm looking for an angle measure. So let's figure out where that angle is. It's going to be QRT. So that's this angle right here. Now, the thing is, if I had this arc measure, Q to T, I would have no trouble finding it. Well, it looks like they give me this angle, which is angle QPT, which opens up to the same arc. All right. Well, based on my theorem, I know that these two angles have to be congruent, which tells me that this angle is 32 degrees. And the arc measure would have to be 64. All right, but they were just asking for QRT, so my final answer is going to be 32. Next one, now we're looking for BDA. So from B to D to A, this little angle right here. Now, there's a lot going on in this picture, and the first thing I want you to notice is that this point is not the center of my circle. All right, well, let's try to use some inscribed angles to help me out. So the one angle they do give me that is inscribed is this one. So BCA is 34 degrees. Now, that angle opens up to this intercepted arc on the left, which is 68. It's going to be double that angle measure. So let's go back to the angle they're actually asking for. They want to know BDA. Well, BDA opens up to the same exact arc, which tells me that it must be the same measure. It also has to be 34, or you could think of it as being half of 68, the intercepted arc. For the next problem, once again, I'm trying to solve for x. So let's figure out where they're pointing at. This expression goes with this inscribed angle. And this expression down here, the 4x minus 3, goes with this inscribed angle. Now, what I want to notice about them is what they open up to. So the red opens up to this intercepted arc, and the blue angle opens up to the same intercepted arc. Now, I don't know how big that arc is, but whatever it is, these inscribed angles must have the same measure because they're opening up to the same exact intercepted arc. So, based on that, I know that 2x plus 11 is equal to 4x minus 3. So we end up with 2x, 14, so x is 7. And that's all they asked for. They didn't really want these specific angle measures. As for the last theorem in this section, it's still dealing with inscribed angles, but specifically for a right triangle. So first thing I wanted to define is an inscribed polygon. It has all its vertices, so the points that make it up, A, L, and G in this case, are on the circumference of the circle. All right, and for my next term down here, if it's a right triangle specifically inscribed in a circle, then the hypotenuse, all right, which as we know is the longest side in my right triangle, so in that case it would be this one right here. The hypotenuse is going to be the diameter of the circle, so it goes through the center of my circle, point X. Now, the reason that's important is because obviously we know the angle across from the hypotenuse is a right angle. And the arc that it opens up to, in this case arc AG, is a semicircle, 180 degrees. So there's my relationship, 180 to 90, the inscribed angle to the intercepted arc. So for the first example, they tell me ME is the diameter, and I know that it is because it passes through the center of circle D. And what I'm looking for is the measure of angle MTE. So here's my angle MTE. I want to figure out the measure of that. Now, once again, I know it opens up to arc ME, which is a semicircle, which measures 180 degrees. Our angle MTE is an inscribed angle, so it's going to be half the measure of the intercepted arc, 90 degrees. And I also knew since it opened up to a diameter on my circle, that it had to be 90 degrees. And for this next problem, they tell me that in my picture, X is 55, this angle down here, and Y is 40 degrees. What they want to know is CD actually a diameter in my circle? Now, if it is, what would have to be true is that this right here would have to be 90 degrees. So that's essentially what I'm asking myself. Is this going to be 90 degrees? Well, what do I know about a triangle? It has 180 degrees total. 2 out of 3 angles, 55 and 40. Well, if I subtract those two, what I'm going to be left with is only 85, which tells me this right here is 85 degrees, which tells me that this arc that it opens up to, the intercepted arc, is going to be double 85, which is only going to give me 170. Which tells me that this right here cannot be a diameter because this is not a semicircle. So the answer is no.